This is a brief lesson that reminds us about quadratics. In this lesson, you will be able to review the basic concepts of a quadratic and identify the key features. The standard form of a quadratic equation is f of x equals ax squared plus bx plus c. Ax squared is the quadratic term, bx is the linear term, and c is the constant term. A, b, and c are called coefficients. A is the leading coefficient, and b is the linear coefficient. If we have the quadratic y equals, or f of x equals 5x squared plus 2x minus 7, 5 would be the leading coefficient, 2 would be the linear coefficient, and negative 7 would be the constant term. The basic shape of a quadratic is a parabola. You'll recall it looks like this, or it looks like this. If a, which is our leading coefficient, is positive, it opens up. That type of parabola looks like this, and it's said to be concave up. If a is negative, the parabola opens down, which looks like this. The lowest point, or the highest point, is called the vertex of the parabola. The vertical line that goes through the vertex is called the axis of symmetry, and the points or points where a parabola crosses the x-axis are called the intercepts, the x-intercepts. Here's your two x-intercepts, and here's your y-intercept. There's always only one y-intercept, but there can be two x-intercepts, one x-intercept, or no x-intercepts. Here's more detailed visual of a parabola opening up. Here's the vertex down here. Here's the y-intercept. Here are the two x-intercepts. This is the line of symmetry, or the axis of symmetry. And you can see that the parabola is opening up. When the a value, which is the leading coefficient, is positive, the parabola opens up, as you can tell by this graph. The vertex has a minimum value, and it's the global minimum. It occurs at the vertex. When the parabola opens concave down, that means the leading coefficient is negative. Here's a parabola opening down. The vertex is a global maximum. Remember, maximum values are always y values, and minimum values are also y values. The basic parabola has the equation f of x equals x squared. If you put in these inputs, these are the outputs that come out. One of the most important parts of a parabola is the fact that it is symmetrical around the vertex. Hence, it has an axis of symmetry. A few important things that you'll need to remember for this lesson. If you have a parabola with the following x-intercepts, -1, 0, and 3, 0. The x-intercepts will be -1, 0, and 3, 0, but the zeros will just be x equals -1 and 3. The zeros are always the x coordinates of the vertex. The other thing you need to remember are the quadrants. The quadrants are numbered starting with the top right, and they go counterclockwise. So 1, 2, 3, 4. You will need this idea when you complete your homework. If a parabola is in the first quadrant, so here's our parabola, it's got to be in the first quadrant, and it's concave up, which means it looks like this. What do you know about the y-intercept? Well, if it's concave up and in the first quadrant, we know that the y-intercept must be positive. Example 2. Given the following parabola, state the x-intercepts. So here are our x-intercepts. So our x-intercepts are -2, 0, and 0, 0. State the zeros. Remember, the zeros are the x-coordinates of the x-intercepts. So our zeros are -2 and 0. Now the interval in inequality notation where it is increasing. We know that the parabola is increasing right here. Now the vertex looks like -1, 2, so it's increasing here. So it's increasing for all x values that are less than -1.